A voltage drop situation is occurring with an ice cream compressor motor that is tripping internally. The motor is on a 20 amp circuit with number 10 wires, running approximately 250 feet. The measured voltage is 116 volts, dropping to 98 volts when the compressor motor starts. The motor's full load amperage is 15 amps. Moving the machine closer to the panel resolves the issue. The service is 120/208 volts. Here are some suggestions to mitigate voltage drop. Firstly, consider adjusting the circuit breaker. A 25 or 30 amp breaker could provide a higher current threshold. Upgrading the wiring might be necessary, so contacting an electrician may be warranted. Secondly, increasing the wire size may help. Installing number 8 or number 6 wires can reduce resistance and voltage drop. However, this might not be feasible due to full conduits. Thirdly, reduce the load on the circuit. Disconnecting other appliances or equipment in the same circuit can reduce the total load. Fourthly, install a voltage booster. A voltage booster is a device that can raise the voltage level of the compressor motor, compensating for the voltage drop. Fifthly, consider a dedicated circuit. Running the compressor motor on a dedicated circuit will eliminate voltage drop caused by other appliances. Other considerations to keep in mind include checking the voltage at the load. Using a voltmeter, measure the voltage at the compressor terminals while it is running. This will confirm the actual voltage drop. Next, inspect wiring connections. Loose or corroded connections can increase resistance and contribute to voltage drop. Inspect all connections and tighten if necessary. Finally, test for ground faults. A ground fault can cause excessive current flow and voltage drop. Use a multimeter to test for any ground faults on the circuit. Now, let's elaborate on each of these potential solutions. Adjusting the circuit breaker involves replacing the existing 20 amp breaker with a higher amperage breaker, such as 25 amps or 30 amps. This allows the circuit to handle a higher current before tripping, potentially accommodating the compressor motor's inner current during startup. However, it is crucial to ensure that the wiring is rated for the higher amperage. Number 10 wire is typically rated for 30 amps, but local electrical codes should be consulted to confirm. If the wiring is not rated for the higher amperage, it must be upgraded to prevent overheating and potential fire hazards. It's important to understand that simply increasing the breaker size without addressing the underlying voltage drop issue is not a long-term solution. It might prevent nuisance tripping, but the motor will still be operating under a reduced voltage, which can lead to overheating and premature failure. Increasing the wire size is a more effective way to reduce voltage drop. Larger wires have lower resistance, which means they can carry more current with less voltage loss. Number 8 or number 6 wires would significantly reduce the voltage drop over the 250-foot run. However, since the conduits are already full, this option may not be feasible without major modifications to the electrical infrastructure. The voltage drop can be calculated using Ohm's law and the wire's resistance per foot. Online voltage drop calculators can also be used to determine the appropriate wire size for given load and distance. Reducing the load on the circuit involves identifying other appliances or equipment that are connected to the same circuit as the compressor motor. If possible, these other loads should be moved to a separate circuit to reduce the overall current draw on the original circuit. This can help to improve the voltage at the compressor motor, especially during startup when the motor draws its highest current. A voltage booster is a device specifically designed to compensate for voltage drop. It works by increasing the voltage at the point of use, ensuring that the compressor motor receives the proper voltage even when there is a voltage drop in the circuit. Voltage boosters are typically installed near the compressor motor and require a separate power source. They are available in various sizes and configurations, so it is important to select a booster that is appropriate for the compressor motor's voltage and current requirements. Installing a dedicated circuit involves running a new circuit directly from the electrical panel to the compressor motor. This eliminates the voltage drop caused by other appliances sharing the same circuit. A dedicated circuit ensures that the compressor motor receives the full voltage from the panel, regardless of the load on other circuits. This is often the best solution for critical equipment like compressor motors that are sensitive to voltage variations. Checking the voltage at the load is a crucial step in diagnosing voltage drop issues. Use a voltmeter to measure the voltage at the compressor motor terminals while the motor is running. This will provide an accurate measurement of the voltage that the motor is actually receiving. If the voltage is significantly below the rated voltage of the motor, it indicates a voltage drop problem. The voltage should be measured under load, meaning while the compressor motor is running. Measuring the voltage when the motor is off will not provide an accurate representation of the voltage drop. Inspecting wiring connections is another important step in troubleshooting voltage drop problems. Loose or corroded connections can increase resistance in the circuit, leading to voltage drop. Check all connections in the circuit, including those at the electrical panel, the receptacles, and the compressor motor terminals. Tighten any loose connections and clean any corroded connections. Use a wire brush or sandpaper to remove corrosion from the terminals and connectors. Apply a corrosion inhibitor to prevent future corrosion. Testing for ground faults is essential for ensuring the safety and proper operation of the electrical circuit. A ground fault occurs when current flows from a live conductor to ground. This can cause excessive current flow and voltage drop. Use a multimeter to test for ground faults on the circuit. Set the multimeter to the ohm setting and measure the resistance between each live conductor and ground. The resistance should be infinite or very high. A low resistance reading indicates a ground fault. If a ground fault is detected, it must be repaired immediately by a qualified electrician. The electrician will need to locate the source of the ground fault and repair or replace the damaged wiring or equipment. If the issue persists despite trying these suggestions, consulting with a qualified electrician is highly recommended. An electrician has the expertise and tools to properly diagnose the problem and implement a safe and effective solution. They can perform a thorough inspection of the electrical system, identify any underlying issues, and recommend the best course of action. Remember that working with electricity can be dangerous, so it is important to take precautions and follow safety guidelines. If you are not comfortable working with electricity, it is best to leave the work to a qualified electrician. NEC Table 310.15 provides guidance on allowable opacities of insulated conductors. It's crucial to adhere to these guidelines for safety. When calculating voltage drop, use the appropriate formula which takes into account the wire length, current, and resistance. Ignoring voltage drop can lead to equipment malfunction, reduced lifespan, and increased energy consumption. Ensure all electrical work complies with local electrical codes and regulations. Using undersized wiring can create fire hazards and is a serious safety concern. Consider using a clamp meter to measure the actual current draw of the compressor motor during operation. This will help verify if the motor is drawing excessive current, which could contribute to voltage drop. If the compressor motor is old or nearing the end of its lifespan, it may be drawing more current than it should. In this case, replacing the motor might be the best solution. Check the voltage rating of the compressor motor to ensure that it is compatible with the supply voltage. If the motor is rated for a higher voltage, it may not operate properly at the low voltage. Use a power quality analyzer to monitor the voltage and current waveforms in the circuit. This can help identify any harmonic distortion or other power quality issues that may be contributing to the voltage drop. Harmonic distortion can cause increased current flow and voltage drop, especially in circuits with nonlinear loads. Consider using a three-phase power system if the load is large enough. Three-phase power is more efficient and can reduce voltage drop compared to single-phase power. Ensure that the electrical panel is properly grounded. A poor ground connection can cause voltage fluctuations and contribute to voltage drop. The grounding system should be inspected regularly and tested to ensure that it is functioning properly. Consider using a step-up transformer to increase the voltage at the compressor motor. A step-up transformer can compensate for voltage drop and ensure that the motor receives the proper voltage. The transformer should be sized appropriately for the motor's voltage and current requirements. If the voltage drop is caused by a long run of cable, consider using a cable with a lower impedance. Cables with lower impedance will have less voltage drop for a given current. Consult with a qualified electrician to determine the best type of cable for the application. Ensure that all electrical connections are clean and tight. Loose or corroded connections can create resistance and contribute to voltage drop. Use a wire brush to clean the connections and tighten them securely. Apply a corrosion inhibitor to prevent future corrosion. Consider using a surge protector to protect the compressor motor from voltage surges and spikes. Voltage surges and spikes can damage the motor and cause it to fail prematurely. The surge protector should be sized appropriately for the motor's voltage and current requirements. If the voltage drop is caused by a utility problem, contact the utility company to report the issue. The utility company may be able to improve the voltage at the service entrance, which will reduce the voltage drop in the entire electrical system. Remember that electrical work can be dangerous, so it is important to take precautions and follow safety guidelines. If you are not comfortable working with electricity, it is best to leave the work to a qualified electrician. Proper wire sizing is paramount to avoid overheating. 110.14 See details termination temperature ratings. Remember to energize the circuit before working on it. Verify with a meter and lockout tag out as needed. Consult with a qualified electrician for any electrical work.